In section 3.1, we'll be talking about the chain rule. The chain rule is used to find derivatives of composite functions. So composite functions are functions that have a function inside of another function. And so the best way to think about this is to think about an M&M. So an M&M has an outer piece, which is the candy shell, and then the inner piece, which is the chocolate center. And so our outer function here is f of x, and then our inner function is g of x, which we'll call u in a second. So when you're going to take the derivative of a composite function, it's important that you recognize those two parts before you start taking the derivative. So we'll practice that now. So before you want to rewrite it, you might think about writing it with parentheses so that you can more easily see the inside and the outside parts. So if we have y equals 1 over x plus 1, you can think of that as x plus 1 to the negative first power. When I see this in parentheses, I now have a better idea of what my outside part and my inside part is. So my outer part is the parentheses, the negative first, and then my inside part is this x plus 1. So my chocolate in this case, my u, is x plus 1. So that's my inside part. And then my outer part, my candy shell, is something to the negative first. And that something was our u. Okay, so our inside part is the x plus 1, the outside part is to the negative first power. Let's try that again with sine of 2x. So the parentheses aren't written in there. Sometimes they will be for trig functions and sometimes they won't be. So I have sine of 2x. I can see my outer function here is the sine, and my inner function is the 2x. So my inside is 2x, and my outside is sine of something. That something is the u. Okay, next we have square root. We've practiced this one before. So when we have square root of something, that is to the 1/2 power. And so my outer function here I can see is to the 1/2 power. That's my outside part. My inside part is the 3x squared minus x plus 1. So u equals 3x squared minus x plus 1. My outside part was to the 1/2 power, so it's something to the 1/2 power, and we'll replace that something with the u. Last one, when you see tan squared x, that really means tangent of x, the quantity squared. So we always want to rewrite it like this. This first way is just a shortcut way so that we don't have to write it with parentheses. We make sure that if the square is on the tangent, then it means tangent of x, the whole thing, squared. So again, I recognize my outside piece is the squared, and then the inside part is the tangent x. So my u is tangent of x. My outside part is something squared, and my inside was the u. So in that first part, we haven't even talked about the derivative yet. We were just identifying the outside and the inside parts of our function. So when we want to take the derivative of something like f of u or f of g of x, the derivative, this is Leibniz notation right here. You'll see this sometimes. It's the derivative of y with respect to u times the derivative of u with respect to x. Usually what we're going to see is this rule over here. So the derivative of f of g of x, where f is your outside function, g is your inside function. So that is going to be the derivative of the inside function, or sorry, the outside function. And then what I want you to notice, and this is really important, is you leave the inside the same. and then after that you multiply by the derivative of the inside. And so again, this is where our M&M analogy comes into play. When you think about eating an M&M, if you were to just suck on it, your chocolate or your candy shell would melt first. So the candy would melt outside. So that's my derivative of my outside. But the chocolate would stay whole until all the candy is dissolved, and then my chocolate would start to melt. So I've got the derivative of the outside, leave the inside the same, and then times the derivative of the inside. So in example 2, we're going to find the derivative of x squared plus 1 to the third. So I can recognize that this is a chain rule problem because I see a function inside of another function. So something inside of something else. So I need to recognize what the different parts are, my outside and my inside. I can see that my inside is x squared plus 1. My outside is something to the third power. So when I'm going to take my derivative, dy dx, I'm going to take the derivative of the outside first. So I have something to the third power. So the derivative of something to the third power is 3 something squared. So I can pretty much just ignore the inside right there. I'm just taking the derivative of the outside function. Then I leave the inside function alone, x squared plus 1. Then the last step, I'm going to multiply by the derivative of the inside. So when I look at the x squared plus 1, the derivative is 2x. This would be an okay way to leave our answer, but we're going to go ahead and simplify it. So usually you can just multiply these coefficients together. So 3 and 2x is 6x times x squared plus 1 quantity squared. You do not need to expand that anymore, and that is our answer. So in general, and this is a power rule like shortcut, if I have a function u to the power of n, so u is some function here, not just a variable, and I take the derivative, I like this rule better. Again, I think it's a little easier to see, u to the n. I use the power rule like normal, n u to the n minus 1, but then I just have to make sure to multiply by the derivative of the inside. And so when you look at your Stuff You Must Know cold sheet, you might see some derivatives that have u's involved, and that just means it's using the chain rule in that rule. So let's try to find some derivatives now. In part A, we have 3x minus 2x squared to the third power. So again, I can recognize my outside function as something to the third power, and then my inside function as 3x minus 2x squared. So I'm going to take my derivative of the outside function, so just 3 something squared. Then I leave the inside the same, 3x minus 2x squared, and then multiply by the derivative of the inside. Make sure you use parentheses here, 3 minus 4x. So if you have more than one term, or even if you have like negative signs, it's nicest to use parentheses there. It's required if you have more than one term. With the negative, it's more of a nice thing to do. So you can simplify that if you want, as 9 minus 12x, distribute that, or you could leave it factored, it's up to you. But what you don't want to do is expand anything with an exponent. And that's our answer. In part B, we have a similar type of problem, however, it's not in the format that we want. So you might want to rewrite first in exponential form. So we have x squared minus 1 squared, and then I'm taking the cube root of that. So rewrite it with your power form, x squared minus 1 to the 2/3. Now I can easily see my outside and my inside functions. So when I take the derivative, taking the derivative of something to the 2/3. So that's 2/3 something to the negative 1/3. And I always do it that way and leave the inside blank, so I'm focusing on the outside where I'm taking the derivative. I leave the inside the same, x squared minus 1, and then I multiply by the derivative of the inside, which is 2x. Then I can go ahead and simplify that. I'm going to rewrite this in radical form. So in the numerator, I would have 2 times 2x, that's 4x. The 3 is still in the denominator. And then I have the cube root of x squared minus 1. And that would be my final answer. For part C, you might look at this and say this looks like a quotient rule problem. It's a quotient. You could use quotient rule, but there's actually an easier way to think about it. So what I want to notice here is that in my numerator, I just have a single term. So if ever I have only a single term in my numerator or denominator, that means I could rewrite it maybe to use a different rule, especially if that term is a constant. So if this is a constant, I can just rewrite this as -7 times 2x minus 3 to the -2nd. So I'm going to make that degree negative now. Usually chain rule is easier to use than quotient rule or product rule, so that's the method we want to use if we can. So my derivative is -7 times -2, that's 14 something to the -3rd. I'm going to rewrite my inside part, 2x minus 3, and then I multiply by the derivative of the inside. So the derivative of 2x minus 3 is 2. I could leave my answer like this, or in this case I'm going to go ahead and rewrite it, 28, the 14 times 2, over 2x minus 3 cubed. And that will be my final answer.